So just a quick introduction for myself. My name is Lincoln Lavoie. I'm with the University of New Hampshire Interoperability Lab. I'm a senior engineer there focusing on all of our broadband technologies, and so we consider kind of Wi-Fi an integral part of that since it's used so widely in broadband deployments. And I'm also the technical chair for the Broadband Forum, which is where the TR-398 was actually developed. So kind of quick introduction of who we are if you're not familiar with us as an organization. We're part of the University of New Hampshire. We've existed for more than 30 years, essentially doing this work with industry to promote interoperability, promote conformance to standards. Essentially, we're serving, one of the ways that we are described as the Switzerland of networking, where we provide a very neutral ground for vendors and service providers and operators and chipset companies to all basically come together and work to develop these materials, to develop this testing, develop their own products, and actually kind of solve a lot of these problems without having to necessarily do it in full competition or something like that against one another. We are part of the university, so it is, a fully nonprofit organization. But when people hear university, they kind of think tuition dollars and stuff like that or state funding. But we actually are tied so close to the industry. 100% of our funding comes from this work that we're actually doing with the industry. And then as a natural kind of progression of that's enabled us and made us work directly with industry organizations like the Broadband Forum or others to essentially promote and develop these type of testings and work very closely with our test and measurement partners to make sure that we can instrument and actually implement this testing in a real world way. So before kind of diving straight into what is TR-398 and the kind of the minutiae details of the actual test cases, I want to kind of back up and talk a little bit about like the motivation of this and where did it come from. Obviously, it came from the Broadband Forum. That a lot of what the Broadband Forum sees is needs from the operators, and they kind of sometimes drive some of the development focus. And so, they were kind of seeing increasing demands on their Wi-Fi networks and their deployments, or their Wi-Fi usage in their deployments. One of the ways that this sometimes gets described is how many times have you gone to your friend's house, anywhere like that, and said, "Do you have internet access?" No one asks that question. What's the question that everyone asks? What's the password on your Wi-Fi? What this has translated to in broadband world is essentially Wi-Fi is synonymous with broadband access or internet access. And if there's poor Wi-Fi performance, it's the broadband's fault. And so the service providers have seen kind of an escalating cost to support that in their deployments and in their world. And they've responded in a couple of ways. There's obviously, the obvious solution of managed Wi-Fi offerings, right? So we're gonna augment the services that we're offering to try to kind of promote and move that along. There's a lot of deployment of kind of like the proprietary multi-AP solutions that are coming out from there. And then the one that's obviously we're talking about today, they went to the Broadband Forum and they said, we really need some help in trying to kind of understand what is the performance, understanding what are our performance requirements, and how do we kind of communicate with the industry to do testing, to be able to kind of do pre-qualification on new devices that might be coming onto our network when we're looking at deploying new technologies or new vendors or new partners, and kind of having that to basically be able to kind of serve as a communication on that language. And so that kind of came from where that motivation of the Broadband Forum started this work. Like I said, Broadband Forum is made up of essentially the entire broadband industries, from network operators down through vendors, chipset manufacturers, labs, and test and measurement equipment manufacturers. So it's really the whole industry kind of coming together to cooperate. It gives a really great forum essentially for the operators to describe their needs and their requirements and to be able to enumerate those and really enumerate those in a global fashion, right? So it's not what are the Wi-Fi requirements in North America versus Asia versus Europe. It's what are the Wi-Fi requirements or the performance requirements overall, and can we kind of get those to a common, globally agreed standard to then be able to kind of make it the easiest for all of the vendors that are trying to support all of these different deployments all around the world from that. The work that does that is essentially consensus and contribution driven. So what does that mean? That essentially means that there's not a single person holding the pen. There's not a single person dictating these performance bars. They're agreed. And I think that's really important when you start thinking about something like TR-398, where you are an actual performance test plan. It's something that is obviously going to be used by the operators, or the quote unquote end customer in that case, to essentially evaluate a product. And so we want make sure in all this development process that you're not taking the pen and handing it exclusively to the end customer, because the operator requirements are always check everything on the list and everything works at the absolute top peak performance, whether or not that's the theoretical boundary or above the theoretical boundary, because that's what their demands tend to be. So we have to kind of couch that against what is the reality, how are these things actually doing that, and then what's the actual focus and abilities of the devices in the world today. The overall, the ask from the operators didn't kind of come and say, do TR-398. It said, deal with Wi-Fi challenges and stuff like that. TR-398 is essentially the first quote-unquote product that's come out of the organization to fit that purpose, but there's actually a couple other things that we're going to talk about, or I'll just kind of mention at the end of this, of where are the things coming down the road and what's next. So now that's the background of 398 that we've got to. So I wanted to talk a little bit about kind of what is the test coverage, where are we coming from. So it's focused on that carrier grade piece more than anything else. So we wanted to establish essentially what are those performance requirements, those performance needs for an operator. You're going to notice when we get kind of into the details and when you see some of the other stuff, it is focused on kind of technologies that are there today. So it's not, hey, let's test 4x4 spatial streams on the maximum available AC implementation that might be out there now to get that gigabit number throughput or something like that. Why is that? Pretty simple answer. Because the quality of experience that the customers are judging the operators on are based on stuff like this. And these guys don't do 4x4 spatial streams, they do 2x2 commonly. So it's trying to be kind of fit for purpose in terms of dealing with an approach for that. And I realize that I'm presenting to a webinar and I held up my phone for the room. So I'm talking about the cell phone device. Really kind of, or the mobile devices, the small devices being not 4x4 capable, more 2x2 in solving that problem. So it's really a kind of that pragmatic approach to the testing with an emphasis on what's deployed. We also realized that in trying to get this work done and get it done in a timely fashion, we weren't going to be able to boil the ocean for the first release. And so we kind of honed in on that specific thing. So if we talk about what does it mean for that carrier grade, so kind of jumping back to the top there, what are the things and parts and pieces that make it up? And so those are kind of the big yellow bullets on the right-hand side there. You've got a little bit of RF performance, but it's really kind of that coverage, that bandwidth. Those are kind of the things that every end consumer sees right off the bat, right? Like, does it work all across in my home? Does it give me that full coverage? And what's that bandwidth that I have available to it? From an operator's perspective, there's also some other stuff of, I've got to deploy this and it's got to be stable. Like, the old adage of rebooting the router, they're trying to kind of get beyond that a little bit. So that's where you see the long-term stability testing coming into there. They're obviously looking at capacity. So the number of devices that are seeing in the networks are having to be supported on the Wi-Fi networks continues to increase. And so trying to make sure that there's some coverage and a plan to address that. And then lastly, but not least, what's happening when operators are having to deploy this kind of into the dense solution space, right? So what happens with interference from other existing networks? The multi-tenant buildings, all of that are an actual reality in their deployment. And so all of that boiled down to the essentially what is the TR-398 performance test plan. And this brings something unique to the industry, as it really is the first that I'm fully aware of kind of industry agreed absolute performance test plan. So that means that it actually gives a pass-fail judgment based on kind of an industry agreed bar of what is performance and what does that actually mean. From that perspective. And so that really creates a nice kind of common language, common framework for the operators to be able to talk to the customers or the vendors and the suppliers and work back and forth, kind of talking apples to apples when they're looking at comparing devices. So I kind of hit on this a little bit. Like, obviously it's strong term, near term focus on the deployments and coverage, key issues on performance, stability, coverage like that. Talking a little bit about like how do we go through developing these metrics, because obviously developing performance metrics is something that's really sensitive. So One of the things that I think is a big strength of the Broadband Forum is that it has a number of years of experience in essentially developing this type of performance testing numbers across the industry, growing out of the DSL space, right? So there's been DSL performance testing for many, many generations of technology today, and even on to the newest generation. And so they have a very good process by which they work through the development of these numbers in a cooperative fashion from all the vendors involved. So it was taking numbers across real devices, across multiple chipsets, looking at how do you size a reasonable bar that will basically deliver that performance requirement, allow some differentiation from devices that is the operator's key ask, but then also kind of backing the operators off that cliff face of setting the performance bar at the theoretical maximum, which left sometimes to their own devices will happen. And so being able to kind of have that whole process, I think, works really, really well. The other thing that was really built into this was there's a lot of focus on kind of the repeatability and well-documented testing. So I think that's another kind of core strength to the way this has been done. So we really focused in on defining the requirements of the test environment, defining an approach to the testing where you would actually be able to kind of hone in on running it repeatably, being able to have something that was run in one lab or an operator's lab or a vendor's lab or a third party's lab be kind of an apples to apples comparison, and be able to, like I said, kind of have that same kind of common language or that common exchange point between those generating the results and those that are consuming the results. And lastly, I just kind of threw it at the very bottom of the slide here, was some definition kind of terms, vocabs that you might hear or see throughout the Broadband Forum in terms of our development. So WT and TR are essentially kind of the pre-published and then the published version of the spec. So the TR is that published one that you saw out there today. The WT would be the internal stuff, and then a study document would be something that's basically under study in the forum. There was actually an internal study document that led to the development of the TR originally, of what are kind of Wi-Fi performance requirements for that kind of carrier grade piece of it. So as you're kind of getting familiar, or if you're getting involved with the work in the Broadband Forum, just having some terminology helps a little bit. So I said we hit right upon 398 in terms of that emphasis on repeatability and that definition of where we're going from that perspective. So one of the things that 398 did was it defined two different kind of implementations for the testing and what their exact requirements would be on those, without trying to specify a specific tool vendor or a specific test implementation kind of in a prescriptive way. And so what I'm trying to really emphasize here is that there's nothing that prevents doing it in an open air environment. There's nothing that prevents it from doing it in a single chamber solution, or there's nothing that prevents the testing from being implemented in the multi-chamber solution, as long as there's a way for demonstrating that those implementations produce the similar and comparable results. And so what you see is the definition on things like ingress noise into your environment at minus 100 dB total at 80 megahertz bandwidth, essentially centered on the channel of interest where you're doing your testing. So there's a way of kind of defining what that test environment has to do, what the needs are, without necessarily driving into it must be vendor X, vendor Y, vendor C's implementation and how you do that. And then the other thing to realize is that while the setups kind of look very general here, the individual test cases do describe additional requirements above and beyond that. So they can change the number of stations that are needed, how you're generating your impairments, kind of additional things above and beyond this. So that the setup kind of gives you the top level version of this, then you have to kind of drill down into each individual test case as you're looking at fully implementing this. So how do we do this in our lab? So we have one of our current setups right now where we essentially have an octoScope stuff on the left. This provides about 80% or so coverage of TR-398 as it stands today. We're migrating this summer towards the PAL 6 implementations to get the 100% coverage of 398, as well as setting up for AX testing that's probably going to go into future specifications of things like TR-398, as well as dealing with supporting things like roaming and mesh and 802.11ax. So that's the setup that we chose to implement in the lab. That meets the requirements of the 398 testing, and it provides us kind of the ability to do above and beyond things as well. Throughput measurements in terms of what's required in 398, it's based on iPerf. It does provide requirements that you can actually do it with other test tools. Again, the strong focus in Broadband Forum stuff is to never be prescriptive of a specific test implementation. We get around that a little bit with the iPerf and being able to talk to something that's an open source, open available tool. So that's starting to kind of become a little bit more of the norm in terms of how you can reference something or provide a pointer to kind of a reference implementation that everybody in the industry has agreed to, since it's open source and everyone has open availability. The test plan does provide some specific recipes for this, as well as some specific requirements for this in terms of it wants to run on top of Linux. There was a lot of concern about like whether other operating systems would actually impact kind of different coloring to the results. So it was focused on adding something with a Linux operating system with kind of a modern kernel. There is a kernel number specified in there, but it's basically that or better. And, kind of some minimum systems performance in terms of number of CPU cores and RAM and such like that would be able to run through the performance requirements from what's in 398 today, with the 11AC 2 special streams kind of being the top of that range. The measurements are based on TCP for the throughput, and then UDP is kind of used kind of as a background filler if you're needing to do the fixed rate cases. One of the things I think is you're going to see change a little bit in the industry. We were kind of talking a little bit about this morning amongst ourselves. You're starting to see kind of a change in the industry focus overall. So this is kind of outside of the Wi-Fi space, but more just how do you do measurements on real live networks that it may be different from TCP. So if you look at what's out there today, every home consumer, every broad consumer, probably the business consumers, I'm sure you guys have run it in your own offices, go to speedtest.net or some proprietary solution, you run a throughput test, and that's all passing HTTP back and forth and blocks of data. But if you look at that in comparison and contrast to some of the newest, most modern protocols out there, especially stuff that's used on streaming, you're kind of starting to see some of that stuff progress towards multiple UDP streams being pushed onto the network in parallel. And so what's happening is there's some work in the Broadband Forum, there's work in the ITU, there's work in the IETF that's actually start to look at, like, when we're doing throughput measurements, when we're doing network performance measurements, maybe we should start to kind of align those closer to what is kind of the bleeding edge on actual use cases on the live network. And so you're going to maybe see some of that start to shift towards UDP. So in the lab, how do we actually go about implementing this? You saw a lot of examples of kind of the Python automation stuff. One of the things that we're bringing out in our space is Test Sentinel. So we've got about 20 years of development experience that we've dumped into doing automated testing, largely growing from, again, broadband testing and DSL, being able to control and automate and touch upon the tools and the test and measurement equipment and be able to control that and have that in a way that exposes those interfaces that make kind of an easy building block mechanism. So we kind of derive or abstract away all of the test and measurement equipment, whether it's octoScope or something coming from someone else, to what we would term a device driver. Those device drivers expose things that we'll talk about in a minute called like kind of a test action, and then test actions get dragged and built together to do that. The system then automatically dumps all of that measurement data back into a database where you can then do post-processing and create the reports and the data visualization at any point from the test. So you're not slaved to making sure that you're doing everything live and in time with the actual running of the test. Our philosophy tends to be capture as much data as you possibly can during a test and then sort through that after the fact, because then you can look at it different ways and try to debug and see what goes on in that. And the reason that we've had such a huge focus on developing that automation framework inside the lab is that we really find more than anything else, this really optimizes our ability to have kind of error-free testing. Eliminating that increases the repeatability because of that, and then also it really allows us to best utilize our investment into these test beds, because we can run the testing almost 24/7 in terms of you're not needing somebody to be there pushing buttons and stuff like that. The automation can go overnight, it can go for longer terms and runs, and that really becomes really important when you look at things like TR-398 stability testing that says run this for X number of hours. And do specific operations and stuff, and you kind of can't do that with human resources. That would be mean. It would be mean even to do that to a student. So I'm not going to do that to my interns or my staff. So what do I mean when I was talking about the test action? So it's a little bit of an eye chart, I'm sure, from those of you in the back, but essentially the test actions expose different behaviors of the equipment. So it could be like, start sniffer, start, the client or station, associate to the device, et cetera, et cetera. It's basically whatever is kind of that reusable block or reusable action that you're going to use over and over and over again in your kind of testing. And then we allow a way to essentially build those into kind of a more complex layout, but doing that kind of more drag and drop stuff like philosophy. So you can put things into conditional logic, you can put things into loops, and you can then take that test configuration, that script, and basically save it off and then rerun it later. And you can even, as part of that, specify tunable parameters that you might want to change or twiddle at the start of each one of these different runs. So you can load a test, imagine, and then just twiddle the one parameter and it changes the whole behavior of everything below it, kind of like in a nice, easy fashion. The other thing that this does is, like I mentioned, it's pushing everything into the database kind of automatically as you're going. So it's pushing not only what was the test measurement into the database, but what was the specific actions that you were doing to that equipment or the specific configuration, so that when you are looking at results tomorrow or next week and scratching your head saying, why did it do that? You're not trying to look back through text logs or like understand what was going on. It's kind of all encapsulated in that individual test run at that time. When you're running the test, like what we do is we actually status log essentially everything, including detailed monitoring of what's going to and from the test and measurement equipment. So you might have a tab that's saying, this is what I'm telling the PAL to do, this is what the PAL is coming back. At the same time, you're seeing what the attenuators are doing, and that's coming back. And then you're generating the outcomes of that pass-fail and stuff like that, trying to give some feedback to the users in real time if somebody's actually watching this run. Essentially, when you get that really nervous customer or really nervous vendor that really wants to see how they're doing in real time, making sure you kind of have that haptic feedback. And then, like I said, everything goes into the database at the end of that. The other thing that we've seen, nothing ever works right the first time. Everybody knows that, and you scratch your head and why was it doing that? Why didn't it do that and stuff like that? And so building in the ability to essentially do breakpointing, stopping a test midstream, seeing state variables and what's going on, or just getting, if you've got a device and you're just trying to figure out why it's doing something or why it's not behaving, why is it doing a slow roam, like why is it failing at this threshold, being able to have everything replicate the behavior up until you saw that point and then freeze. And then you can go in and you do whatever you want to the device, additional debugging, if you're trying to collect logs, if you're trying to do something like that, you're able to kind of dig that back and actually see that. So these are kind of like what we've driven towards our TR-398 testing, kind of pulling with us all of our experience in past of test automation and test capabilities to try to make sure that we're sorting through that. Where are we seeing results and stuff like that? So I can't talk about testing without having some talk about the results and where we're seeing for things. And so I threw two up here. This is the spatial consistency. I didn't have time to make the nice pretty polar plot that everybody loves to see when you're talking about rotations. So imagine that, if you will. But this is the medium distance. There's essentially, if you dig into what is the 398 test case for spatial consistency, it says tested essentially with 3 different attenuator values. This is kind of that middle of the range one. And so this is looking at that distance through 30-degree increments of rotation around a device, and then doing that TCP throughput measurement from that. And you can see like it's got a set of required data rates, which you're hitting here, and then the measured throughputs. And so one of the things that I wanted to have in this results is to actually show some failure case, right? So like we had one device that was well behaved right up until one rotation, and then it started suffering kind of that throughput at that specific angle and such. So just to highlight kind of why you want to do this, why you actually want to look at that type of testing, and then you can see that caused some of the variation between the different measurement points, so it wasn't as consistent as it would like to be. Second one, that's the obvious one that everybody thinks about with performance testing, is the range versus throughput, or the walking test, as you will. One of the things that you look at as you're doing that work is essentially there's about 20, I think it's 22 or 26 different test points that you would see in those cases. They're kind of not a uniform spread. The way they got put into the test plan was kind of more focused the number of test points you had on the areas of interest for that, so you can kind of get the knees, as it were, in that roll-off. And again, it's measuring the throughput against the required throughput. So you can see this is a case of, I believe this one is a passing set of results on a device. So you can see that definitely capable. The bars are real and obtainable. And then one of the things that we do just to try to gather additional information, kind of how our philosophy is, we actually do a lot more testing than what 398 specifies. So we might still walk through either every 1 or 2 dB points to gather more additional data. It kind of smooths out that plot, if you will. And it actually gives you a chance to kind of see something like the dip you see here, where it actually kind of happened in between attenuator settings that are the requirement for the 398 for whatever reason. So that would be a case of maybe you want to get back in and debug or look and try to see what happened there. Might have been an anomaly, might have been there's something kind of going on with that one test point. That's TR-398 today, essentially. What is termed in terms of the future work within the Broadband Forum, Broadband Forum documents come out in what's referred to as issues. So the next public release of 398 will likely be issue 2. Keeping my fingers crossed that nobody comes to me and says that there's an error in TR-398 issue 1, in which case we have to do the core agenda and stuff like that. So the next public one we're targeting towards Mobile World Congress, which is where we released this past year in February with the first issue. So we're kind of taking an aggressive stance that we want to try to get a rev done in the next 10 months or so to kind of be able to meet that deadline, get something done by the end of the year, early next year. So what does that mean in terms of things that are going to be going in there, right? So we couldn't boil the ocean on the first rev. We know we left a lot of stuff out of that that's important to the operators. We didn't do anything in terms of client steering. We didn't do anything with channel selection. We didn't do dual band operation. What happens when you have 2.5 and 5 gigahertz at the same time? 802.11x is an obvious thing that everybody's going to want in there, but we're also going to see some stuff like probably the multi-AP stuff starting to appear in there, or some of the mesh, or quote unquote mesh, where you might have just the extender backhauled with one technology and extending the other technology. So a lot of this work will be driven by essentially those operator use cases that you have coming out or coming into the forum as the input for how this is being deployed. And then, as I promised, there's also the other additional VBF work that's going on in terms of the study documents. So like, if you remember earlier, that was the kind of internal study. So there's a lot of look from service provider perspective of what does it take to do video over Wi-Fi, and what are the quality metrics that you look at there. That's driving towards a test plan for basically video over Wi-Fi specifically. So looking not only at the packet and Ethernet type throughput on the wireless network, but what happens when you actually have video on the thing and you're looking at kind of the quality of the video metric on the network. And then that's coupled into the open source work that the Broadband Forum is doing on an open source implementation of the WFA's Easy Mesh technology, and that's being worked in collaboration with the Purple Foundation, which I should have had on that slide. So that's looking towards a lot of like the API definitions and stuff like that, as well as kind of driving back towards other projects that the forum has for how do you manage Wi-Fi, or how does a service provider manage Wi-Fi in the home with things like TR69 or USP. where are we going at the lab? So test plans, we're going to be bringing out 802.11 that actually has a typo that should have said AX this summer. So much in the habit of typing AC. So we're going to be bringing that out this summer as we kind of rev up what we are suing for the gear that we had. We're having plans already existing that are being used by a lot of our customers for the roaming, so we're going to continue to augment them, probably put in some client steering cases, and like I said, that mesh case where it's more just kind of that Wi-Fi extender case where you're using one Wi-Fi technology to backhaul another. Whether or not that's backhauled with AX or if it's backhauled with AC or 2.4 and stuff like that tends to be a little bit more driven by the service provider needs. One of the big reasons that we're trying to kind of run ahead on this is to make sure that we've got data available to then bring back to the Broadband Forums process for the development of those performance numbers. So that was one of the things that took us probably the longest piece in the development process of the Broadband Forum work for TR-398 is because there wasn't kind of a common test plan and an approach to doing this testing. There wasn't a common set of data, so all of us were having to generate this data kind of on the fly as we were going, because you needed the test procedures to then generate the test data according to the test procedures to then drive back to what the performance numbers are. And so we're trying to kind of close that feedback loop and kind of be able to iterate a lot faster on that through this go. And so that's where we are heading over the next 10 to 12 months within the forum, as well as how we're supporting that work at the interoperability lab. And I just had the links there, so when folks have the slides, they have any questions or anything like that, they know how to reach us. So hopefully I'm reasonably close to on time.
Perfect.
And if anybody has any questions, fire away. So crystal ball time, right? Like what's going to happen? We really tried to make sure that when we were looking to our test beds that they were going to be able to cover the roaming and some of the other kind of interesting cases and dual band at the same time, as well as AX. So that's where we were looking to try to make sure that we were kind of getting beyond just the kind of performance tests of one technology N or AC or AX at a time with, kind of the three sets of stations that roam between those different devices.
There's maybe only one here that you might want to take. Why does TR-398 not have any tests which are related to user experience, such as video, audio streams, and data at the same time? Let's suppose the Broadband Forum introduced these tests in the future. How would octoScope accomplish it?
I'll take the first half, you take the second half?
Or you can just take the first half.
I mentioned the I think it's 434 or 334. So it's the performance test looking at, I'll minimize this right here. The 434, that video in premises thing, that's exclusively looking at what happens when you start doing that application type traffic over the Wi-Fi channel. But more interestingly, what happens to the actual video traffic? So it's not just saying, oh, well, video is just data frames and stuff like that. So it's starting to look at how would we approach doing that type of testing, dealing with the video and the video quality measurements that are available now, but having Wi-Fi in the mix as kind of the dependent variable that we're twiddling with while we're doing the measurement from the Wi-Fi video side of things.
We always have a goal, for example, always, by the way, just of supporting 100% of whatever the Broadband Forum test cases are. We're a participant and maintain alignment, but just specifically on this one, how would we do this? Obviously the tests don't exist yet, can't speak specifically, but our devices, for example, the PALs, and you'll see later when we show examples of TR-398 testing today, the PALs being used as the devices. Our PALs allow bridging, so you can bridge traffic through those. It's actually possible to run, therefore, real traffic. We always use iPerf as our kind of base level of testing when we're running traffic, but you can actually set up the system so that you would be bridging real video or real voice traffic through the system. So we have no implementation issues that we would know of to support real traffic profiles, data profiles where you would have some data, some voice, some video, something like that. The system is fully capable of handling all of that.
Yeah. And one of the big open questions for that video work is when you start looking at the video and using that as kind of the measurement technique on top of that, you're bringing obviously the encoder and the decoder and the renderer all into that kind of equation. So we're, kind of working on getting that specified as part of this process. And so making sure that we have that specified is going to kind of drive a lot of what is the test setup and implementation.